Got a past exam question to have a look at. So this is an organic mechanisms question and it's all about radical substitution. Let's have a look. Okay, so we'll just quickly go through the information. So suitable conditions, butane reacts with chlorine, radical substitution. You get a mixture of organic compounds including that C4H9Cl and also compounds D and E. Got to complete the table to show the mechanism for initiation and propagation stages. In your equations, use molecular. So we've got to use molecular formula and we've got to use dots for radicals. So initiation step first. So what are we reacting? We're reacting chlorine. So the chlorine molecule is going to have its covalent bond broken by homolytic fission. They haven't asked what type of bond fission it is in this question, but homolytic fission, and we're going to get 2 chlorine radicals, so we need a dot there. Condition for this reaction, we need UV, ultraviolet. Right, so the first propagation step, we'll take that butane molecule and react it with the chlorine radical. And the thing to remember about a chlorine radical is it will always take a hydrogen off what it's reacting with. Okay, so I always get my students to write HCl in first so they don't forget that's always formed. And the rest of the alkane is now a radical, so it'll be C4H9. We'll just put the dot there. And then the second propagation step, we take that radical we've just formed and we react it with a chlorine molecule, so Cl2. And what that new radical is going to do is it's going to steal one of these chlorines, take its electron as well and pair that electron up. So we're going to get C4H9Cl and we're going to make a chlorine radical. And the last part, organic compound D formed by the substitution of all the hydrogen atoms in butane by chlorine atoms. So basically we're going to swap all 10 hydrogens for 10 chlorines. So we're going to make C4Cl10. But the way it works, and I always say this to my students, every substitution that takes place needs a mole of halogen. So we've got 10 substitutions taking place, so we're going to need 10 moles of chlorine. And every substitution makes a mole of hydrogen halide. So we're going to get 10 moles of HCl. Hope that was useful. I'm going to post loads of these, so keep a lookout for them. All right, cheers, bye.